Assalamu alaikum. Today I'm going to discuss about the unbounded knapsack problem. So, what is unbounded knapsack problem? Given types of item of different values and volumes, find the most valuable set of items that fit in a knapsack of fixed volume. The number of items of each type is unbounded. Introduction: The unbounded knapsack problem arises from the following hypothetical situation. Consider a hiker with a knapsack on a trip. He has to select items to fill the knapsack. Every type of item has a value Vi and a weight Wi, and the knapsack has a weight carry capacity B. Mathematically, the problem is defined as follows. The knapsack problem is the simplest integer programming problem with a single constraint and belongs to the class of NP complete problems. The topic started with the sequence of papers by Gilmore and Gomory. Since then, two books and over 300 technical papers have been devoted to knapsack problem in the last 40 years. Solving unbounded knapsack problem using dynamic programming. Knapsack problem refers to the problem of optimally filling a bag of a given capacity with objects which have individual size and benefit. The objective is to increase the benefit while respecting the bag's capacity. The original problem of number items are limited to once it is used, it cannot be reused. This restriction is removed in the new version unbounded knapsack problem. In this case, an item can be used infinite times. This problem can be solved efficiently using dynamic programming. Problem statement. Given n items, each with associated weight and value, benefits or profit, the objective is to fill the knapsack with items such that we have a maximum profit without crossing the weight limit the knapsack. The unbounded version of the problem we are allowed to select one item multiple times unlike the classical one, where one item is allowed to be selected only once. Example, suppose we have three items which is defined by a tuple and the items are we have a bag capacity 58 in case the optimal filling will be item 3 plus 3 plus 1 plus 1 plus 2. Note the total benefit is 41 plus 41 plus 12 plus 12 plus 2 is equals to 108 with total weight being 57 and this is less than 59. We could have covered all the way like this. Item 3 plus 3 plus 2 plus 2 plus 2 plus 2 plus 2. Dynamic programming approach. We use dynamic programming approach to solve this problem similar to what we did in classical knapsack problem. The only difference is we use a single dimensional array instead of 2D and used the classical one. This is because we have infinite supply of every element available to us and hence we don't need to keep a track of which element have been used. Thus, the array would be dp w plus 1 where dpi indicates the maximum profit and we can achieve with a knapsack capacity of I. Here w the total knapsack capacity, hence our answer would be the dpw. Programmatically, we iterate over all the elements available each knapsack capacity between 1 and W and determine if it can be used to achieve a greater profit. Thus, our DP equation would look something like this. And the surrogate portion, suppose we are given 4 times with weight 1, 2, 5 and 3 respectively and the profits associated with them are 40, 30, 50 and 25 in the same order. The capacity of knapsack is given as 2. And here the first iteration I equals 0 and the second iteration I equals 1. And for the third iteration I equals 2. Now since I equals to W is for knapsack capacity, our iteration would stop. So the maximum profit that we can achieve is dp2 equal 80 by using item 1 2 times as has weight to 1 and profit 40. And here is the implementation of unbounded knapsack problem in C++. And thank you.